Dear students, today we are going to discuss tracing of curves in Cartesian coordinates. Now these are the steps. The first step is to check the symmetry. If all powers of y occurring in the equation are all even, then the curve is symmetrical about x-axis. For example, if you take the curve y square is equal to 4ax, then you know what is this equation? This equation represents a parabola, and parabola is symmetric about x-axis. So if all powers of y are even, then the curve is symmetric about x-axis. Similarly, if all powers of x are even, then the curve is symmetrical about y-axis. For example, if we take x square is equal to 4ay, then x square is equal to 4ay is symmetrical about y-axis. So if equation of the curve does not change by interchanging x and y, then the curve is symmetrical about the line y is equal to x. Means if you interchange x and y and there is no change in equation of the curve, then the curve is symmetrical about the line y is equal to x. For example, if you take the equation x cube plus y cube is equal to 3axy. Now if you interchange x and y, what will be the equation? Y cube plus x cube is equal to 3ayx. So equation doesn't change. So this curve will be symmetrical about the line y is equal to x. If equation of the curve does not change on replacing x by minus x and y by minus y, then the curve is symmetrical in the opposite quadrants. First and third quadrants are opposite. Second and fourth quadrants are opposite. Step 2. Nature of the origin. For this, find out whether curve passes through the origin. If 0, 0 satisfies equation of the curve, then find tangents at the origin by equating lowest degree terms equal to 0. So if tangents are distinct, then origin is a node. If tangents are identical, then origin is a cusp. If tangents are imaginary, then origin is a conjugate point. Now what do we mean by node, cusp, conjugate point? That we shall explain when we take a few examples. Step 3. Find out points of intersection with the axis. For this, we put x is equal to 0, then we will get certain values of y. And then you put y is equal to 0 and you will get certain values for x. Now at these points, you shift the origin and then find nature of the origin at these points. Now how do you shift the origin at these points? Suppose by putting x is equal to 0, we get some value of y, say a, right? So we have the point 0, a. Now in the equation of the curve, you put x is equal to 0 plus 0 and y is equal to a plus y, right? And then from that equation, you take lowest terms equal to 0. We'll take up examples and then it will be clear. Step 4. Find out regions where the curve does not exist. If x square is negative or y square is negative for some range of y or x respectively, then curve will not exist in that range. Means for some values of y, if x square is negative, then because x square cannot be negative, so the curve will not exist for those values of y. Step 5 is to find out asymptotes. What are asymptotes? That also we will explain later on. Asymptotes parallel to x-axis are obtained by equating coefficient of highest power of x equal to 0, provided it is not a constant. So in equation of the curve, you equate coefficient of highest power of x equal to 0. Then you will get asymptotes parallel to x-axis. Similarly, asymptotes parallel to y-axis are obtained by equating coefficient of highest power of y equal to 0, provided it is not a constant. So for finding out asymptotes parallel to y-axis, take coefficient of highest power of y in the equation equal to 0, and that will give you asymptotes parallel to y-axis. Let's take one example. Trace the curve x square y square is equal to a square into x square plus y square. Now you see here that wherever we have x square here, x square here. That means powers of x are even. So curve is symmetric about y-axis. Similarly, wherever y is appearing, y square, so powers of y are also even. So curve is also symmetric about x-axis, right? So if all powers of x are even, then the curve is symmetric about y-axis. If all powers of y are even, then the curve is symmetric about x-axis. So in this case, therefore we have symmetry about both axes. Second step is to find out nature of the origin. Now if you put x0, y0, what will you get on the left hand side? You get it as 0, and the right hand side also it is 0. So 0, 0 satisfies equation of the curve. Now if you find out tangents at the origin, how do we find out tangents at the origin? We find out tangents at the origin by equating lowest degree term is equal to 0. What is degree of this term? Degree of this term is 2 plus 2, that is 4. What is degree of this term? This is constant, and x square plus y square. Degree of this term is 2, this is also 2. So this is the lowest degree term, means x square plus y square is equal to 0. So y is equal to plus minus ix, which is imaginary. So therefore origin is a conjugate point, means curve will not pass through the origin. Although 0, 0 satisfy equation of the curve, but because tangents are imaginary, therefore origin is known as a conjugate point. Next step is to find out points of intersection with the axis. Now put x is equal to 0. What do we get? If we put x is equal to 0, then we get y is equal to 0. And if we put y is equal to 0, we will get x is equal to 0. That means 0 is the only point of intersection with the axis, and we have already seen that origin is a conjugate point. Then regions where the curve does not exist. Now if you solve this equation, simplify this equation, you get y square is equal to a square x square upon x square minus a square. Now if x square is less than a square, then x square minus a square is negative, and this is always positive. So therefore y square is negative. That means when x square is less than a square, y square is negative. That means curve does not exist between the lines x is equal to minus a and x is equal to plus a. Similarly, if you solve it for x squared, then if similarly curve will not exist for region between the lines y is equal to minus a and y is equal to plus a. Now last step is to find out asymptotes. If you simplify this equation of the curve, then equation of the curve is x square y square minus a square x square minus a square y square is equal to 0. Now for finding out asymptotes parallel to x-axis, what we have to do? We have to equate coefficient of highest power of x is equal to 0. What is the highest power of x here? X square appears here, x square appears here. So therefore coefficient of x square is y square minus a square is equal to 0. That means y is equal to plus minus a. Similarly, asymptotes parallel to y-axis are given by x square minus a square is equal to 0. That means x is equal to plus minus a. So therefore asymptotes are x is equal to a, x is equal to minus a, y is equal to a, and y is equal to minus a. So therefore, if you draw this curve, then shape of the curve will be something like this. If you take the first quadrant, shape of the curve will be like this, because curve does not exist between this and this. So shape of the curve is like this. Now take symmetry into account. Because the curve is symmetric about, say, y-axis, so therefore On this side also the mirror image of this curve will appear, and because curve is also symmetric about x-axis, so mirror image of this portion will be like this. So this is a curve which is divided into 4 branches, and origin is the conjugate point, means curve does not pass through the origin. Let's take one more example. Trace the curve y square into 2a minus x is equal to x cube. Now here you see that y square, right, powers of y are even, so therefore curve is symmetric about x-axis. Nowhere else y is appearing, right? Nature of the origin. If you put x0, then we get y is equal to 0. That means 0, 0 satisfies this equation. Now to find out tangents at the origin, we equate lowest degree term equal to 0. Now which is the lowest degree term? 2ay square. What is the degree? 2. xy square degree is 3. x cube degree is 3. So lowest degree term is 2ay square. That means y square is equal to 0. That means y is equal to 0, 0. That means tangents are identical. And when the tangents are identical, then origin is a cusp. What do you mean by cusp? This point is the cusp. There are 2 branches, right? So this point is known as cusp. So therefore origin is a cusp. And then to find out points of intersection with the axis. If you put x is equal to 0, we will get y is equal to 0. And if you put y is equal to 0, then we get x is equal to 0. That means 0, 0 is the only point which is obtained by intersection of axis. And 0, 0, as we have seen, is a cusp. Next step is to find out asymptotes. Now asymptotes parallel to x-axis. What is the highest power of x? 3. And what is the coefficient? It will be plus 1 or minus 1, which is a constant. So therefore there are no asymptotes which are parallel to x-axis. And to find out asymptotes parallel to y-axis, we equate coefficient of highest power of y equal to 0, which is 2a minus x is equal to 0. That means x is equal to 2a. And in the last step, to find out the region where the curve does not exist. For this we find y square from this equation. Y square is x cube upon 2a minus x. Now from here you see that if x is negative, so x cube is negative, 2a minus x is positive, so therefore y square is negative. That means curve does not exist when x is less than 0. Similarly, if x is greater than 2a, then 2a minus x becomes negative, so then again y square is negative. So therefore curve does not exist for x less than 0 and x greater than 2a. So combining all this information, origin is a cusp. This line is the asymptote. Asymptotes mean curve will touch the line at the point at infinity or minus infinity. So this line to which the curve meets at infinity or minus infinity is called asymptote. So therefore shape of the curve is like this. Curve does not exist for x less than 0 or x greater than 2a, and origin is a cusp, and this line is the asymptote. Again you have to draw the approximate figure because you don't know the value of a. Okay, thank you so much.